Good afternoon, good morning, and good evening from wherever you are joining us from. Welcome to our webinar, which we're holding in collaboration with our partner Siemens. So this webinar today is going to be focused on how to move you from brownfield to AI ready. And we're going to be focused more on, showing you how to build a scalable foundation with Siemens Industrial Edge and HiveMQ. So just quick housekeeping. This webinar is going to be recorded and going to be shared with you afterwards. And also, if you've got some questions, please drop them in the Q&A session and we'll get to your questions at the end of this session. Okay, so my name is Kutsai Mandi Teresa. I'm a Senior Industrial Solutions Advocate at HiveMQ. So I take care of thought leadership when it comes to smart manufacturing, unified namespace, and industrial AI topics. And for this session, I'm joined by Martin Feischl, who is the Ecosystem Solution Manager for IT and OT integration at Siemens. So Martin is going to give a full introduction of himself once he starts to do the presentation on his end. Okay, so let's quickly look at the agenda for the day on what we're going to be discussing. So first of all, we're going to start with the key challenges, just to talk about why is it that a lot of industrial companies are failing to really scale their AI initiatives or are failing to address or get value from their AI investments. And then from there, we're going to kind of like give you an overview of how to actually build a scalable data foundation for AI. And then from there, I'm going to kind of like give you also an overview, detailed architecture on what are the different components that you need to put together to actually, build that scalable foundation. And then from there, Martin is going to then start his presentation, and then it's going to go into more detail specifically about how Siemens and HiveMQ actually come together to form that architecture. So as you can see, there's going to be a lot of architectural discussions here. So there's quite a lot of technical details to take away from here as something that you can readily, implement or sort of like get a perspective on where you sit based on your existing infrastructure right now. And we're also going to have a live demo to show this integration or how these two platforms actually enable you to build that data foundation. So without further more to do, let's jump into our agenda for the day. Okay, so first and foremost, let's talk about why is it that AI initiatives actually fail. So I'm sure you've kind of like really heard this many times that a lot of companies struggle to get their AI use cases off the ground because they just don't have the necessary data foundation for it. So we're going to start by getting into details of what exactly do we mean by that. In many cases, the lack of that necessary data foundation usually traces back to the decision that a lot of companies make early on in their digital transformation journey, which is this idea that a single application is going to be like the integration hub for all your operational data that powers your AI. So maybe that's like an MES system or an ERP or historian or sometimes an IoT platform. But essentially, the idea there is that you're directly connecting application to application or device to application in a point-to-point fashion. And if you have been attending our webinars previously, you might have heard us talk about this idea of a spaghetti architecture. There are several reasons why that particularly starves like AI initiatives. So the first set of challenges are really in the connectivity side of things, so to speak. So the first is integration sprawl. So that platform, whether it's a historian or IoT platform, MES, it might have some connectors, a handful of connectors for common system that you can connect and start to see data and that you can use for AI. But the moment you want to scale that, the moment you want to to get data from a wide range of equipment, different vendors, different protocols, some brownfield lines, you start to build your custom connectors one by one, and you're effectively repeating that same process of setting up your connectivity for each and every system or operational system that you want to onboard for your AI use cases. So in many cases, this is an expensive process, both in engineering time and in budget. I mean, I'm sure we've all seen or heard about MES or ERP rollouts that run for years, and sometimes they cost millions of dollars, and sometimes some of them they've actually never really finished, right? And that's precisely because of that long tail where you have to really manually integrate each and every single thing that actually lives on your shop floor. So obviously, if you can't get all of the data that you need for AI, use cases in a cost-effective manner, fast enough, then obviously you're going to have your AI initiatives stall. The second thing is that those links that you create when you onboard different systems to an application is that you're creating a title coupled point-to-point architecture. So when something changes, like at the source, so whether it's a PLC that gets changed out, or you rename a tag, someone has to go and fix that. So you still end up maintaining this web of connections that always disconnect your data sources every time something changes on the plant floor. And for those of you who work on the plant floor, you know that change is something that is constant on the plant floor. You always want to move things around so that you can get your production going. So if every change that you make actually breaks your architecture, then you have a big technical gap that you can't use AI, you can't rely on to you build your AI use cases on. And more importantly, this really doesn't, compound. I guess this is more a friction for a lot of, enterprise companies, where you build something in one site, but it doesn't, carry over to site two, because you've got different equipment. So all this connectivity that you spent years setting up on plant one, you literally have to do the same thing on plant two. So those years actually start to add up again. So from a connectivity standpoint, I guess you start to see a picture of why that would delay your AI initiatives. And when it goes to more on the IT side of things, or the AI side of things, the big issue that you hear all the time again is this idea that there's no lack of context. So your ERP doesn't have like your shop floor context in real time. So as soon as your production order or leaves your ERP system, then it's blind to exactly those minute decisions that are happening on the shop floor. So that context is missing. Your historian doesn't store all the data. In any case, many of the historians that they have that primitive data model, where in many cases it is just storing like a name and a value and maybe a timestamp. So that's something also that you cannot rely on to build your AI use cases. So when your data sort of like leaves all these operational systems and go to a central data platform, so whether you're using a lakehouse or whatever you're using there, you end up getting this data that is raw values and raw data that has got no context as to what asset was involved in that process, what process was running. So there's no meaning attached to that. So again, AI, can't do much with data that doesn't, really know what it represents. So the work of adding that context has to happen somewhere. So now, because you don't have that place where you can find all the contextual data, it means that your data scientists, they end up having to build these data pipelines for each and every use case. Every AI use case has to have its own data pipeline. So whether you're addressing, so for example, an AI-based energy optimization use case, you build up that data pipeline, and then when you move on to predictive maintenance, you do the same thing again to save your data scientists that data. So again, as you can see, there's a big bottleneck there that is involved in as far as addressing all of your AI use cases is concerned. And the other approach that companies take, that they move that data to the data lake. And again, it's mostly IT people who are left to contextualize that data. And IT teams in many cases are not the right people to contextualize OT data, because they don't live in the process. They don't know what good looks like on the plant floor. The meaning that AI actually needs in many cases end up being added wrongly, or sometimes it's actually not added at all. So that kind of like gives you an overview or a clear picture of what are the challenges that many companies are actually running across as they try to follow this traditional approach of data integration. So now let's talk about what the actual solution look like. What is the right approach to address these challenges? So again, instead of relying on that one particular application as the integration hub, you need to replace that with a data infrastructure that acts as your data foundation layer. So that is the big shift in my experience that many people that I speak with struggle with that idea, because here effectively you're no longer connecting applications directly to applications. You are actually plugging applications and devices to a common data infrastructure. And I say it is a shift because many OT people are used to this idea that you have to connect to a server, you have to poll a server to get the data. So that's kind of like that this first big shift, that decoupling, breaking your architecture. So what that means is that all your systems, from both your plant OT and plant IT networks, they're now sharing data using a standard communication protocol and a standard data format, without having to maintain those direct connections, or without having to know the intricate implementation details of all the other systems in your plant, which you would actually have to know if you are connecting everything directly. You have to know each specific register, whether it's a Modbus that you need to get the data from, each specific OPCUA node ID, you need to have that as part of your architecture. But in this case, you're effectively plugging into an abstraction interface, as it were. So what would make that possible is that data foundation needs to support a publish subscribe model of data integration. In this case, it's an MQTT based architecture. That means your data sources don't talk to consumers at all. Again, as I mentioned, they publish data to like this infrastructure in an event-driven fashion. So whoever needs the data needs to subscribe to receive the data, and applications just publish data to a specific topic. We're not going to go into the details of exactly how MQTT works, but that kind of like that's the general idea. And so what that means is that the PLC or machine or whatever system on the shop floor doesn't need to know what analytics application is actually consuming its data. So it's effectively pushing it from the edge, or rather through that industrial edge platform, as you see later, acting as that interface between your brownfield equipment and then this data foundation. No, but more importantly, this idea that when you're adding a new consumer to your data foundation, you're not touching the data sources, right? So because previously when you're adding a new consumer, again, you need to change the data source, you need to change the address or whatever you need to do. So here you're adding a new source, you're not touching the consumer, you don't care what the consumer is whether it's connected or to what address it's actually exposing its information on. So what does that actually benefit you in real terms? So first of all, that process of onboarding data sources, of connecting your equipment for AI use cases, which usually takes months and years, that is reduced down to weeks, and in some cases even days. So kind of like we've had customers who actually started to connect all of their data within, or all of their equipment within days, because effectively you're plugging into an infrastructure, right? You're contextualizing data and pushing it out into an infrastructure, and then you get all of your data as soon as possible. And the second benefit about that is that you've got reusability. So again, that's a big shift again from this legacy way of data integration, because previously for you to use data, you're connecting to all these services. If you need data from 100 services on the shop floor, it means you're connecting to 100 services, and then you can't reuse that data because it's going to one specific application. But in this case, it means that you are reusing that data from your operational systems for many different use cases, right? It can be used for multiple AI use cases because you're tapping into that same data hub, right? You're defining your events at once to say, these are the events that we want to collect. This is the data that we want to collect. You define those as events, and then you push those whenever and when that data changes, right? And so that ability to really reuse the data gives you the agility to try as many hypotheses as possible, because data access is no longer possible. Because I mean, for a lot of companies, that's exactly what it is. It's AI use cases, they start as a hypothesis, right? Like you don't really know what is exactly that you want to try out. So if trying out a hypothesis costs you months, just to try a hypothesis, you can already see how that becomes a big friction. But if you've got a pool of data where you come up with a hypothesis, that there's a pool of data source that I can tap into, try it out, build a model. If it doesn't work, go again, try it. That gives that agility to experiment, and that helps you get your AI use cases to scale faster, or to production rather. So, but how do you actually build that connectivity and common event hub? Because again, we know that a lot of equipment on the shop floor are legacy. We've got brownfield systems that don't natively talk MQTT. So your data foundation, as you can see there, it's actually in two layers. You've got first the connectivity and contextualization layer, which allows you to connect to operational systems in their native language, in their native protocols, collect the data, contextualize the data, and normalize it, and then put it into a common format. Once you have it into a common format, and then you publish that contextualized payload as an MQTT message. But obviously, just putting the data into a common format or a common protocol is one thing. What you need to be able to do is to then make that data semantically accessible within that data foundation, within that hub, by presenting it in a way that represents the structure of the business. So in other words, you're unifying your data into a semantic hierarchy that represents the current state and events of your business. So for a lot of you who are familiar with the idea of unified namespace, that's essentially what that is, making your data accessible in a semantic understood way. So this is the first big part, really fixing your AI problem, specifically, because if you notice here, that contextualization problem that we spoke about, where data scientists and your IT team need to set up that pipeline, that contextualization is now a first-class layer within the data foundation itself, right at the edge, right next to where the equipment that have the data are seated, right? So your data doesn't leave your plant as raw tags, rather as values, contextualized events. They carry the asset context, process context, all of the meaning that you need to actually start to build your AI use cases. And then so what that means is that as a data scientist or your data scientist, they don't need to build those data pipelines. They don't need to go to all these different systems whenever they've got a use case that they need to address. They simply, again, go to that common data foundation, get all of the data, whether they want to persist that information, they want to use the real time for inferencing, that's a different issue. So again, more importantly, this is like a repeatable architecture, right? So you can repeat that same architecture, you can then take it into a different plant because it's not dependent on a specific proprietary application, right? It depends on abstraction. You abstraction all of these operational systems, so you can repeat that same architecture across your different systems. So let's kind of like talk more about what that actually means, because I think we talk about context a lot, and I mean everyone talks about context. If you see all the stuff around LinkedIn or different webinars or companies, but it's often not clear what that context actually means. So I want to kind of like peel into this a bit to discuss what that looks like. So in many cases, if we took, for example, an energy monitoring application. So it's not very useful to just monitor how much energy was consumed, right? Rather, what would be more meaningful is for you to know how much energy was consumed when you were, say, making a specific product or a specific batch, on which piece of equipment, at which site, by which operator. Because this is all this context that the AI needs to be able, when you build that model, it then able to determine whether the issue with energy consumption is the equipment, or is it the product that you're making, or the way that that product is actually being made, or the different set points, right? So to create that picture, you need to collect all of these meaningful events from your operational systems. You timestamp them, contextualize these events, and then you publish them into your data infrastructure. So, for example, from an OT equipment perspective, this could be your operational state changes, right? So, what mode is that piece of equipment is in? So maybe this could be your pack ML state based state changes, or this could be what operator the actions or what actions is the operator taking during startup, right? Maybe that could be the reason why you're getting bad quality issues, or maybe you are getting a malfunction, right? Or so you're getting all of these batch phases. Whenever a batch phase starts, whenever it stops, all the events, you're collecting those deviations, alarms, and everything. And on the IT side, you're getting all of these meaningful events whenever a maintenance order is being processed, right? Different changes of the maintenance order, or whenever you get some lab inspection results, you want to publish those with context into that data foundation, so that you get that context of exactly where, what is the surrounding context for every piece of data is published into that one foundation. And in some cases where maybe you've got an AI agent, maybe it's listening into even inventory changes. So maybe you want to be able to switch something, or maybe you want to do something whenever there's change in your inventory. You want to have something that is listening in and getting all of that context, right? So, but more importantly, because this is a big question again that a lot of people ask to say, but I can't not depend on real-time data only for AI. So I need that history. I need to train the data. I need, if it's an agent, that needs to have the context of exactly what actually happened in the past. So now we are actually persisting those high fidelity or that highly contextual events and state changes into your data store. So whether you're doing that on site, or whether it's it's in a lakehouse, the point is that you're persisting highly normalized or highly contextual data for all your AI use cases or for your agentic operations. So I've got a different slide where I'm going to go into detail about exactly how that enables more specifically your agentic workflows. But for now, let's kind of like just quickly look at an example use case. Also, actually, I think this is the agentic AI workflow architecture that we need to look at. So for example, as many of you know that agentic AI presents an opportunity to actually move beyond prediction AI, where you are building a model and generating a prediction, and then someone has to interpret what that actually means and recommend an action or take a decision or whatever the case may be. There's still that decision intelligence gap, right? There needs to be someone who's skilled enough to interpret what that is, right? And in many cases, a lot of companies don't have those skills, right? Or maybe many people who are skilled enough to actually confidently take decisions based on AI recommendations actually leaving or are retiring. So there's that gap, and it's a whole different topic that we can get into. But this is an opportunity that automating those workflows agentic AI presents. But obviously, for agentic AI to really be effective in actually closing that decision intelligence gap, it needs to have access to different perspective to your operational data to kind of like get a sense of what is happening right now, what does it mean, or what matters actually to the business. So that same foundation actually helps you deliver on those operational realities, right? So whether it's a trigger that gives you an indication of what's actually happening right now. So if for those of you who work on the shop floor, you know that an operator or engineer actually reacts to events, right? So whether it's an end of shift event, or it's a where they need to create a shift report, or whether it's a work order that has changed and they need to do a certain workflow, or whether it's a piece of equipment that goes down and they need to generate a maintenance order. All of these are workflows are triggered by events, right? So it's based on events, and then they take a standard operating procedure. So just like those operators, your agents, AI agents, depend on those events to execute the workflow. So those workflows, they flow through your unified namespace, your data foundation, and they become those triggers for those workflows that you need to carry out. And because they're already contextualized, the agent knows that not just something, not just what something happened, but exactly which asset, which batch, which order. So they get an event that has got context, but more importantly, because you're persisting those events, the agent is also able to look up, to better able answer, some follow-up questions that it may have to say, maybe is this a normal deviation, right? Has this thing happened before? What was done last time, right? All of this knowledge that is typically not collected, right, can be synthesized from the state changes and the event changes that you are collecting from your data foundation, and using them to train your AI model, or to really orchestrate your agentic workflows. So just to kind of like give you an example of what that architecture, how that enables that scalability, as it were, kind of like to make it a bit concrete. So if you look at it from a high level perspective, like for example, if you have got an AI-based energy optimization use case, like actually a multiple of use cases. So you could, actually have like every plant, run on the same foundation, publishing the same contextualized events using a consistent data model. So, this could be, you're continuously monitoring your energy metrics that are contextualized with production and business data, or you're collecting your energy data, that you're combining with production context using common data foundation. So what that does is that it opens up some real and scalable AI outcomes, because you're using the same data foundation. You're not kind of like repeating that connectivity infrastructure. You're not repeating the contextualization each time, collecting the data for each specific model, right? You're reusing that same standard, approach. And so that allows you to also correlate the results, right? Because you're standardizing across your entire enterprise. You can correlate the results, and you can also set benchmarks that you can then use in that regard. So now let's kind of like, just before I hand it over to Martin, let's look at what that detailed architecture looks like. For those of you who may be wondering that, okay, this is well and good, but how does that actually map to my existing infrastructure? What you're looking at here is kind of like your typical, ISO 95 functional hierarchy model from L1 to L4. You've got your L1 systems on L1, your L2. So typically you'd want to have that, industrial edge platform that does that contextualization and connectivity piece that we spoke about earlier, that connects to your, brownfield equipment or even your modern equipment, collects the data, also connects to your plant IT systems, and does that contextualization that we spoke about, whether it's a work order that has been generated, whether it's an inspection result from an LMS system or whatever the case may be, and then contextualizing this and projecting it into the unified namespace on one side. And then you then have like an enterprise unified namespace that then gathers all of this context and then again maintains that consistency across your entire enterprise. So that kind of like gives you a general view. So now I'll kind of like hand it over to Martin to go more into details on exactly what that looks like concretely from a Siemens Industrial Edge ecosystem perspective and from a HiveMQ perspective. Over to you, Martin.
Well, perfect. Thank you so much, Kutza. I think that was a very perfect handover from the HiveMQ deep dive to now to our industrial edge solution from Siemens. So let me quickly share my slides.
Yes, now we can see the slides.
Yeah, perfect. That's good. Thanks for the feedback again. Okay, then let's potentially start first of all with some numbers we gathered within a lot of customer discussions, with a lot of discussions we had with our customers and engagement. So this guy you can see here on the left-hand side, right, with a lot of paper here in the background. So I think it's very often a typical production, especially also still in Europe and also in other countries all over the world. So when we engaged with our customers, they were really reporting us that there was a big problem with this kind of data integration challenges, and they are really hindering our customers with this kind of modernization efforts, right? So, and almost the same percentage with 85% said, okay, AI would be a very good boost for my production to make my company even better. But this data integration topic, and I think Kutza already pointed it out very, very well, without having all the data in place, you're really, it's impossible, right, to have all the data in place. And also to improve your production via AI if there are no data in place, right? So it's really the first initial step to make your production more efficient, to use AI in your production, is really providing the data from the machines, from the production, and provide it for the AI tools. And definitely when you also have some kind of siloed systems, that's also hindering your production. So I brought with me today a concrete case study from a customer project. So first of all, we have from the industry perspective a manufacturing customer with 10 production sites globally, right? We have
sorry to interrupt you again, Martin. Would you go into slide mode because I think we're still locked on the first slide.
Okay, so because that seems, let me quickly try again to share once more. So hopefully now it's working.
Okay, yeah. Looks like it's working now.
Yeah. You can see also when I'm painting something on the slides, right?
Yes.
Yeah, perfect. Thank you so much. Yeah, perfect. So as I mentioned, I brought today this customer profile from industry, manufacturing, 10 production sites globally. We have mixed vendors, Siemens, and of course also other PLCs are equipped in the machines. And we have, you imagine, 10 factory sites. We have on the one hand side all the facilities, all the brownfield facilities. And of course, for example, 2 years ago, we built up a new facility with a greenfield environment. And so we have brownfield and greenfield. From an initial situation, we have, of course, also some kind of highly fragmented production environment, again, with these siloed systems. And from the machine's perspective, we have multiple communication protocols, beginning with OPC-UA, Modbus TCP, Profibus, Profinet, any kind of proprietary interfaces. And the challenge, of course, we have with this kind of siloed brownfield and greenfield systems, we do not have any kind of we do not have any kind of end-to-end visibility of our production performance from the OEE. We have a lot of downtime costs due to the unplanned outage because, of course, there is any kind of production stop and we do not know when it's happening, why it's happening, and so on. And we still just remember you didn't see it on this kind of on this picture here. So we have a lot of paper in our manufacturing. So we have a paper-based manufacturing. And of course, to get rid of all these kind of challenges, we evaluated concrete use cases. The first use case is based on MES, all the execution also combined with that traceability functionality and also production optimization. So one of the possibilities is to just connect all of my machines with any kind of IT systems. And you can see, and Kutze already pointed it out and also said the same word, I wanted to use this kind of spaghetti architecture. So lines and connections everywhere you can see. We have here on the IT level our PLM software. We have our MOM and also any kind of cloud analytics software. And all of the machines are connected to each of these systems. But imagine one of the PLCs is broken down here, and you would like to equip the machine with the new PLCs. So you have to reconfigure all the connections again and again and again. And to get rid of this potential solution, I would like to introduce, after this not scalable and not contextualized and this error-prone and time-consuming realization of our challenge, I would like to introduce a new way of working. So again, we have our customer example, our customer example, we have our 10 factories. On the one hand side and on the other hand side, on the top row IT, we have our IT systems again. We have an ERP system. We have, of course, to realize our use case, an MES system and cloud analytics. And not to avoid this kind of spaghetti architecture, we're introducing the message broker from HiveMQ. And luckily, the IT systems has the MQTT interface already in place. But as I mentioned, we have a brownfield area. So a lot of protocols are not able, and a lot of PLCs are not able to communicate via MQTT, and even no contextualization of the data is possible. So we are introducing here now our industrial edge solution, which is providing a suite of connectors for several protocols. So we are talking here about applications running on an edge device, which can be either software or hardware based. And I always make the comparison with my mobile phone. So there is a hardware, for example, in that case, it's a Samsung mobile phone with Android operating system on any kind of application on it. And it's very similar to that what we have here in place. We have our Siemens hardware, or as I mentioned, also software-based. It's an edge device running several kind of applications. And an example of this kind of application is our suite of connectors with connectors, for example, for a Siemens PLC. These connectors are able to connect on the one hand side non-standardized interfaces, brown and greenfield, and also standardized interfaces, brown and greenfield. But it's also connecting and lifting the data up from the PLC level up here to this edge level. Now we would like to give the data a contextualization and information, and we are doing that with our industrial information hub. So this application giving the data this contextualized information and also provides the data via MQTT on our HiveMQ's message broker. But that is just one hand side. Now we also have the question in mind how to scale this functionality for our other 9 factories. And the good thing is with the Siemens Industrial Edge, that is very easy to scale the solution. And why? I'm just coming in a few minutes back to that. So if we now dig a little bit deeper and take a look on one of these industrial edge devices and also here of our production side. So we have our intra-plant logistics connected via OPC-UA. We have here some kind of forming with S7 Plus protocol. There is going to be something to be milled, where a FANUC controller is built in, and we have to communicate via focus protocol. There is the assembly with Modbus TCP, and at the end we have our packaging, the packaging of our products. that is connected via Ethernet IP. And as we would like to do also some kind of visual quality inspection at the end, we also need the vision connector. So all of this protocol, which you just can see here, are application for Industrial Edge and are already available on our marketplace. So the southbound interface is done. The next topic is the northbound interface via MQTT. Done. We would like to provide the data via OPC-UA for other applications. It's also available in our Industrial Information Hub. Also done. The data sync to other kind of applications done. Data storage, for example, if there is connection loss to the enterprise message broker because, I don't know, someone disconnected the Ethernet cable, then the Industrial Information Hub is storing the data here. And when the connection is re-established again, then all the data with the right data stamp are provided on the message broker. And one of the most important points is asset modeling, and also giving the data and contextualized information is also done via our Industrial Information Hub. Now coming back to the question why it is so easy to scale it to other factories. Siemens Industrial Edge is based, as I already mentioned, on edge devices which are located very close to the machines. But one of the most important pieces of industrial edge computing from Siemens is this industrial edge management, where we can centrally from one point of the world can download software applications. You can download firmware updates. And that is a very important point because we having our own operating system in place, which we can update here with Industrial Edge. It's Linux based. So everything which runs under Docker also runs on our Siemens Industrial Edge devices. And you can also update, for example, any kind of configuration here. For example, you mounted any kind of configuration files like the connection to a PLC or anything specific. You can easily update from one central place, and you do not have to go, for example, with a USB stick from device to device to device. So that is really the main differentiator from Siemens Industrial Edge to other competitors. But that is not all. Siemens Industrial Edge is also an ecosystem. That means that we are providing also third-party applications on our marketplace. And just scan here the QR code, and you can see here also the HiveMQ Edge is available on our Siemens Industrial Edge marketplace. For example, you would like to use the functionalities which are already built in our HiveMQ Edge, then this is an official application provided by HiveMQ for our marketplace, for our ecosystem, which just can get there from our marketplace and run on our Industrial Edge devices. And if it just came back to our previous architecture, so instead of the Industrial Information Hub, you can run and use the HiveMQ Edge on Industrial Edge level. And the big benefit is having HiveMQ Edge on Siemens Industrial Edge. You can easily connect via MQTT to our connectors, onto our suite of connectors, where you can also use, for example, a 7 Plus connector, which is only provided by Siemens. You can have other kind of connectors which are available on our marketplace. Just go to our marketplace, check out. We have a lot of connectors, Ethernet IP already mentioned, Modbus, TCP, Focus, and so many more. So you can easily adapt and enhance the functionality of HiveMQ Edge with the suite of connectors. But now I would like to give you a short live demo to also give you the chance on see a little bit more than just slides. So, and now I'm really hoping that everything is working with the sharing. I hope you can give me very short feedback whether you can see my Siemens screen again.
Yes, we can see it.
Perfect. Thank you so much for the feedback. Okay, then let's start here with our short live demo. So here in our live demo, we are showcasing a filling bottling machine, right? So we're putting something into the bottle that you can see here. And now we are, and here is also the progress of the introduction of the live demo. You can see here that we are now on Industrial Edge level. And all the several icons you can see here stands for a separate application. You can see here the OPC-UA connector, the S7 connector, also S7 Plus, which is a difference to the S7 protocol. More performance, easier connection, also the possibility to browse the data. And you can also see here our Industrial Information Hub, our IIH semantics, which is providing and giving all the contextualized data and how to configure the Industrial Information Hub. Therefore, we just have to click on the common configurator. And if we do so, first step of everything we would like to do is getting the data from a data source. In that case, we would like to read the data from an OPC-UA server. So we just have to click here on the OPCOA connector. We would like to add here a connection. You type all the required information in, the name, the OPCOA server URL, and so on. So, and that you can see here now that we can click here on browse text, and with browse text, we are getting all the data which are available on this OPCOA server. So we would like to read their 3 data. We just have to select those 3 data. Then we have to choose the acquisition cycle. We can read data down to 10 milliseconds, and also the acquisition cycle or mode is possible to choose here. We can select the cycling on change and also read and write. So that means that we can also write data back to the OPCOA server. For example, especially for our use case with order execution, when a new order is coming from the MES system, it's going down the message broker from HiveMQ, is going down the industrialized level, and industrialized is spreading it to all the PLCs via OPCOA in that case. So we add that to the data source, but that is just the first step, right? So we are now lifting the data from the PLC up to the edge level, but we would like to give the data now a contextualized information. That is the next step we have to do here, right? So you can see here again our data format based on ISO 95. So you can see here that is the company, that is the location, and that is now the line. And there is also a second line here in this office. And there we would like to add now the data which we have already had, right? So we can also select here and copy it, some kind of already previous prepared configuration, so not re-engineer everything again and again. So we have here all the data available, which already on the edge level. Now we would like to give this kind of data as semantic information. So we just choose, drag and drop. Now we have the applications here available, and we can also give it a shorter tag to save also bandwidth by shifting the data from A to B. You can see here now we have here this actual pressure coming from the OPCOA server. And the next step is we lifted the data up to the edge level. We gave that a semantic information. Now we would like to send it to the HiveMQ message broker. Therefore, we just have to click on sync the data. And there we can choose sources from the North point of view. So we have there several kind of possibilities. But you can see here we can lift the data to another instance of the Industrial Information Hub. Insights Hub is our cloud operating system. Sensei is one of the AI based on cloud solutions from Siemens, where you can directly evaluate and give a value via artificial intelligence to your production. In that case, we choose just the generic MQTT broker. We are typing in here all the requirements and the credentials for this MQTT broker. So this MQTT broker is on cloud level. Kutza just gave us before the credentials we have to just fill in here. And then we can provide the data here via MQTT on the message broker from HiveMQ. And you see, okay, now it's green. We have the state that it's connected to the MQTT broker. And then we just have to choose which data we would like to provide on the data broker. Just drag and drop again. We just would like to provide the data from the attributes. We take both here from the line, drag and drop. And then you can see here that both of the tags are now provided on the enterprise message broker. So now we lifted the data to the message broker with the MQTT Explorer. We would like to see whether the MQTT messages are already on the MQTT broker. So with the MQTT Explorer, we can check whether they are already there. And you can see here both tags are there. And what you can also see, and that is also very important, I already mentioned, if there is a connection loss between Edge and the MQTT broker because someone disconnected, for example, the Ethernet cable, so the tags are stored on industrial edge level in the meantime and are provided on the message broker after the connection is re-established again. But that is only the easiest use case, right? So we just provided the data on the MQTT broker. Now coming to a real customer example, we have an application available. It's so-called the step time analysis for performance insight. So that is on cloud level on Insights Hub. It's our cloud operating system based on AWS, where we helping our customers to optimize their production. So we are really now gaining the value out of the data which we are getting from the message broker from HiveMQ. We have again here our filling tank. And we would like to analyze whether in one of these steps of the production, you can potentially remember back of these production steps we have to do from forming our milling and packaging. And we would like to evaluate whether of one of these steps we are not in the time we actually would like to produce this kind of step. And our step time analysis is directly analyzing that, right? So we see now here in our step time analysis that it's showcasing us when something is happening in our production site. So everything which is red here, so it's not in the right time frame. So we have directly seen in which of these time frames we have to optimize, because there we are taking more time than we actually have to produce this kind of stuff. Okay, coming back to my presentation, I would like to summarize it a little bit again. And Kutsai, would you like to do it for our Siemens Industrial Edge solution?
Yeah, absolutely. Yeah, so I mean, as you can see, obviously here, as you want to connect to your brownfield equipment, you definitely need something that is proven, industrial grade, and runs right there at the edge, close to your equipment. And certainly, without a doubt, Siemens Industrial Edge is perfectly, suited for that specific role. And more importantly, you're not just really, consuming or really just using one, piece of the puzzle. You've got like a holistic, portfolio, so you can kind of like manage all of your shop floor data in one place, right? You're not stitching some, point solutions or some tooling all over the place. You've got this holistic portfolio that allows you to manage all of your shop floor data into in one place. And then, of course, more importantly, you've got that native MQTT connectivity on top of that whole library of of Brownfield protocol that allows that easy integration with the HiveMQ ecosystem, as using MQTT as that event backbone that you spoke about for contextualizing your data foundation, agentic AI, and things like that. And so yeah, that's kind of like really the most important part, that really getting that proven solution, industrial grade, that really allows you to be at the center of your operations.
Perfect. And also let's do it for the HiveMQ message broker. So with HiveMQ, we really set on the market leader for MQTT message broker. You have a reliable and secure MQTT broker with definitely an enterprise-grade security and interoperability. There is no single point of failure. And of course, you have an enterprise-proven scalability with 100% MQTT compliant and data persistence. And solution, when Siemens and HiveMQ is coming together, you just saw in our architectures, we can really lift up the values out of your production if you count of this combined solution. And with that, let's go to the Q&A.
Yes, absolutely. Yeah, so we've got quite a lot of questions here, which is good. I think we've got quite some time to go through all of them here. So I will just start with the questions here. We've got one from Anthony Chan, who's asking, how is the security risk of going to this UNS model? So I think I'll just give it a shot at that, Martin. So I guess the unified namespace, actually, a lot of companies find it attractive for that very reason, that it actually doesn't it doesn't expose your shop floor equipment to vulnerabilities, because you're not opening up a whole lot more ports to allow access from the IT. Rather, you're opening one outbound port through the DMZ that sends all your MQTT traffic out. So you think effectively you've got that, a data diode, as some would like to call it, that allows you to have that, one way going out, opening that, outbound port, and not receiving anything coming back to your shop floor. All right, and I think we've got Zaid here, who's asking any tips, perhaps tools for doing good data governance on this interesting enabling system and valuable use cases. Do you want to answer that one, Martin? Oh, I think you're on mute.
Sorry, what was the question again?
Yeah, so basically, Zaid is asking about, do you have any tips and perhaps tools for doing data governance on this that enables the system and use cases. So I kind of like maybe just answer this from a HiveMQ perspective, and then you're going to also tell us more from the Siemens perspective. So basically, this is exactly why HiveMQ built HiveMQ Pulse, which is that layer that that allows you to enforce those governance policies on your unified namespace data, so that you don't have data, ungoverned data that is flying around. You're able to really enforce those governance rules that makes sure that when your data hits your downstream systems, whether it's your AI models or your lakehouse, it's already validated that this is good data.
Yeah, of course. And I also just mentioned that with our Siemens Industrial Edge solution, it's really depending on what you have in your production site already, right? So our colleagues, of course, they are really when you, for example, wherever you're located, of course, I am the global responsibility, but wherever you're located on the world, we have our local colleagues, which helps you whenever there is a requirement for how can we provide the data in the right manner on a unified namespace from HiveMQ. So we can really have there a deep dive session to evaluate what is the right format, what is the right protocol, how can the solution look like.
Yes, perfectly. So we've got another one from Abdi Moshiri. I hope I'm pronouncing it correctly. So basically it's asking, I want to know how data from many sources of IT and OT are ingested and synchronized. What is the tool for ETL and synchronization from different sources? So this is, basically I think what you saw there, Martin, show that this the contextualization is at the edge, basically, where you are ingesting this data using those protocol, translators or protocol converters, and then you contextualize the data and then you publish it or push it as an event. So there's no sense of synchronization. This is asynchronous communication because you're publishing these as events, and whoever wants to consume that data will consume that data whenever they join online or whenever that data is made available. Martin, if you've got something to add, feel free to jump in and reinforce that.
Yeah.
Okay, and then again here we say Zakaria Natiji is asking, operationally, we can see in shop floor that not all equipment, PLCs, either connected to systems are MQTT native. A layer of data pre-treatment is needed for OT level. So yeah, I think that we've answered that question, and I think Martin has already demonstrated that as well. Yeah, that's and then right. As the unified namespace increases in complexity, given that multiple sites have multiple turbines, where does the payload schema actually live? Is Data Hub validating at the broker, or does consistency still depend on publisher behaving? So this validation of the unified namespace can actually happen at two levels. So if you notice, for example, from a HiveMQ perspective, you've got data validation that is happening at the edge. So which means within your Siemens Industrial Edge platform, if you're running HiveMQ Edge, you're able to apply Data Hub validation to actually validate data before it even leaves the edge. But still, you're able to also apply that at a broker level, right? At a plant level, or even at an enterprise level. So it really depends on where you want to enforce those schema validations. So Data Hub, to answer your question, Data Hub actually lives in different HiveMQ release state as it were. How much impact and usefulness UNS has in the electric utility grid and substations? Right. I mean, I would say this is, first and foremost from an MQTT, standpoint. These are kind of like, precisely the use cases that MQTT was built for in the first place, right? Because these are kind of like your typically remote, sites that have got limited bandwidth, and they've got like high volume data that needs to be all consolidated into that one platform, and without requiring the cloud-based or backend system to pull all of these different systems. So having that unified namespace and all these systems push data from the edge into that MQTT layer or unified namespace layer is kind of like really the use case for all these systems.
Absolutely. And I would like to add there that especially in this kind of electric utilities grid and solutions, which are very decentralized, right? So especially this kind of central message broker with HiveMQ, and also, for example, in combination with the decentralized industrial edge devices, so we can really lift there a lot of value. We have a lot of use cases already and customer projects where we have industrial edge in place at some kind of electric utilities, especially in Europe and in other countries all over the world. So definitely a good solution.
Perfect. Okay, and then this next one, I don't know, Martin, if you're able to answer this one. So they're asking, do you read historical data from a historian even if high availability system is not available?
That is, of course, a little bit kind of a tricky question. So it depends on what you use on industrial edge level, because we have applications available on industrial edge which can run in a redundant way, of course, on the one hand side. So that means that there is an application running on an edge device. There is a next edge device or a second edge device where it's the same application running, and they are synced and providing the data in a redundant way. If you really need high availability, that means, like, for example, like Kubernetes does and provides that. So we also have a special solution available in this regard. So if you need this, then please reach out to us. Then we can have a follow-up discussion on this kind of Kubernetes stuff with high availability. In combination, of course, with HiveMQ message broker. I'm always talking about how to bring the data in a redundant way to the message broker from HiveMQ, of course.
100%. So we've got another question from Mobin, perhaps the last one. They're asking, is there any standard philosophy for unified namespace for contextualization? So, I mean, I guess so, because obviously unified namespace is predominantly based on MQTT architecture. And if you have had some, discussion, the good thing about MQTT is that, it doesn't prescribe, a payload, right? A structure. And the bad thing about MQTT that it doesn't prescribe a payload structure. So that kind of like, gives you that flexibility to be able to define the contextualization that you need to follow. But that actually doesn't also close, the opportunity for you to actually pick a standard payload. So if you want to use a standard OPCUA information model that you want to, publish to the unified namespace, you're able to do that. But generally speaking, you're using ISA 95 for the semantic hierarchy of the unified namespace, and then using different ways of contextualizing the data, standardized, non-standardized, or customized to your specific enterprise. And it's just quickly before we close, Abdi is asking if there's a white paper about the topic is an access to. So yeah, we'll reach out to you, Abdi, and provide you with the relevant white papers for these topics of discussion. And with that, that brings us to the end of this session. Thanks again, Martin, for joining me. And thank you to everyone who attended this session. Really appreciate your time here today. Thank you.
Thank you so much. See you.